Okay, let me share my screen. So before going to the content, I'm giving my introduction. So this is Suraj from Dassault System. So in this session, I will take care of the generative shape design and generative sheet metal design. Okay.
Okay.
Hope my voice is audible to all. Let me clear.
Okay, sir.
Yeah.
Visible, sir. Visible, sir.
Okay. The screen also visible.
Yes,
So
yes.
okay. So before going to start the generative shape design, we need to understand that why we are using the generative shape design. Okay, so basically generative shape design is used to define a complex shape of the part. Okay, sometimes a complex shape will become into your part that is not possible in your normal part design or in sheet metal design. That time we will go for the generative shape design uh, for a design the complex portion of the part. So ultimately our want is to create a solid body to best our design intent. However, the model may be include the surface geometry integrated to the solid model. Okay, so later we will go to in-depth look at the generative shape design process. But the important consideration of the key point is first, whenever we will create the generative shape design, let me enter into the workbench. Okay, so whenever we will go to this generative shape design, we need to draw some. Okay, we need to draw some wireframe design. Okay, we need to take some base for create the surface. Like in your part design, we are taking some sketch for creating the 3D model. Similarly, in your wireframe design, we can take the sketch as well as the wireframe 3D element. Okay, then after we will go for the wireframe surface and solid geometry from an integrated set of model capability allow us to capture the design intent. Okay, so whatever which complex shape you want to achieve, okay, that you can define in wireframe design. Then we'll go for the surface design, then you will go for the solid model for your design. Okay, there are some steps while creating the surface base feature. Okay, first is accessing the generative workbench. So how to open the generative workbench? You can go to directly start shape and here generative shape design. Okay, just go to the start. Again I am telling start shape and generative shape design. You may write if you want to write a note. Okay, so after that it will ask to you enter into the part name. You can enter your part name. If you want to do this generative shape design in a hybrid mode, you can check on the hybrid mode. Okay, so I don't want to do the design in hybrid mode. I want the normal non-hybrid mode. Okay, my surface should be in geometrical set and my parts or a solid model should be in part model. Okay, that I want in non-hybrid design. Okay, so once entered into the generative shape design workbench. Okay, this is one of the way. If you want to use it frequently, if you want to use it frequently, for that what you need to do is means you need to set this generative shape design workbench as your favorite list. Okay, so you need to set the generative shape design workbench as a favorite list. So how to make it favorite list? Okay, so you need to go for these tools and here you will find the customize. Okay, so after going to this customize, you will find the start menu. Okay, I have set some um, favorite list like sketcher, part, assembly design and drafting. Okay, I want to do this favorite list on this generative shape design. Okay, I just click on the generative shape design and I need to set as favorite by click the arrow. Okay, you can make you can give your own oscillator for shortcut key. Okay, so for now I'm not giving any oscillator. I am just putting this generative shape design as my favorite list. Okay, so after set the favorite list, you can see when you will go for this start, you will find the generative shape design in your favorite list. Okay, this order may be vary according to your uh, set of favorite list. You can find directly the generative shape design in the welcome to CATIA v5 also. Okay, so you can directly switch from here, from the welcome to CATIA v5. Okay, this is how we are entering into the generative self design. Is there any doubts on this, how to enter into the generative self design and all? Hello, hope my voice is audible to you.
Yeah, yeah. No, okay, sir. Okay, sir. Please
Okay,
continue.
okay. So after that, the process I'm telling you, just first accessing the generative shape design, then you need to create some wireframe design. You can see in my screen I have some wireframe like reference element, point, line and plane. Okay, this is available in your part design also. Okay, if you cover this part design, you will find the reference element like point, line and plane. Okay, except that we'll find some other wireframe design, wireframe element like your projection, combined surface, then sealed out or a reflect line, sealed out. Then here it is the intersection, parallel curve. Then inside you will find the rolling offset, then a 3D offset, 3D curve offset. Then by default you will get the circle, corner, connecting curve and conic. Here in this spline, you will get the spline tools, then you will get the helix, spiral, spine, then conquer, isoparametric curve, then curve from equation. Okay, so these are some wireframe element you will find in generative shape design. Okay, then after creating the generative shape design, you need to execute the surface model or a surface geometry. Okay, as it is a geometric element, so whenever you will create the wireframe or surface design or a surface element, it will store in a geometrical set. As I am in the non-hybrid design. Okay, so in surface you will get some tools like extrude, revolve, sphere, cylinder, offset, different types of offset. Then your sweep, as you know, 21 types of sweeps is available in generative shape design. We will cover all this thing. And here one of the advanced sweep is there, additive sweep and a fill multi-section blend. Okay, so this is how we will create the surface from the wireframe design. Okay, then after creating some surface, we need to relimit or we need to trim or join the whole surface, as we will create the surface in different uh, profile. So we need to refine that one. For that we have operational toolbar. Okay, so in operational toolbar, first one is your join or then healing. Okay, so join is basically to join the surface if it is connected to each other. If the surface is connected to each other, then we will go for the joining process. Okay, then healing, let you create some surface and between two surface there should be, there may be some gap. Okay, to fill that gap we'll go for the healing function, and we will know how to calculate the healing diameter, means healing dimension from the connect checker or connect checker analysis. Then we will put the healing dimension for fill the hill fill the surface. Okay, then we'll go for the smooth curve. Okay, then here it is smooth curve means if you are creating any curve. Okay, sometimes it will create some segment. Okay, for making it smooth, like for tangency continuity or curvature continuity, for in that condition we will go for the smooth curve. Okay, then here it is surface simplification. Okay, so surface simplification is nothing but like if you have a surface and that surface have lot of surfaces inside it. Okay, but it is like in a one surface. The just assume the surface is light in one surface. Okay, in that condition we'll go for the simplification of the surface, then on trim. Okay, by mistake let's suppose just assume that you have you just create one surface, but by mistakenly you trimmed and you don't know for the previous process what you did in the what you did after the trim. Okay, so in that condition you will go for the untrim so that it will take to you the original trim position or original surface. Okay, then here it is disassemble. Okay, sometimes there are some edge in one surface. Okay, if you want to make it one surface or the number of edge of the surface, then that time you can go with the disassemble the surface. Okay, so this is how we will join. This is all about the join and the disassemble the process. Then here it is trimmed. So split and trim is basically used to cut the unwanted element of the surface. Okay, sometimes you will create the surface perfectly, but sometimes it is some extra position surface is will be there. To cut that one or to remove the um, extra surface, you just use these tools like your trim, split, and here it is your screw surface and remove face edge and all. Okay, remove face, it is also an interesting tool. So it is basically used to remove the edge fillet like uh, dress up features. Okay, it is basically used to remove the dress up features like your edge fillet, fillet, chamfer. Then you, if you have a multiple variable fillet, that time we can use for this remove face and edge. Okay, then as usual in in part design, say fillet is nothing but if two surface is not joined. Okay, and you want to do the operation for fillet, then you can go with the shape fillet. And here edge fillet if two surface, it is vice versa, like if two surface is joined together but you want to perform some fillet, in that condition you will go for this edge fillet. Okay, then styling fillet, it is something which is used in freestyle design. Okay, then here face to face fillet, it is same. You maybe know this one because it is also same in part design. And here it is train transient fillet. Okay, so then here chamfer and here some translation features like symmetric, rotate, and then mirror, scaling, affinity, and axis to axis. Okay, then extrapolate is generally used to extend the surface. Okay, so this is how we will go for this generative or step creating the surface based feature. Okay, so after that we need to check some analysis whether our surface or curve is correct or not. For that we need to check with connect checker analysis, and one is your feature draft analysis or draft analysis, you can say. This is also you can find in your part design. Okay, now we'll go with the wireframe design. Make a side for surface operational and analysis. Wireframe design. So I won't go for this reference element. Why? Because it is already covered in part design. Okay, I will just give a small glimpse of this wire reference element like point. So while creating the point, you can see you will find different types of point. One is coordinate, on curve, on plane, on surface, circle, sphere, and ellipse center, tangent to curve, between. Okay, you can try with this different types of pointer. Let me try with only this coordinate. Okay, In coordinate you will find x0, y0 and z0. Okay, now you can see the point is created, but now you can see it is created in the separate geometrical set. Why? Because we did we start the generative shape design with non-hybrid mode. Okay, if you will select the hybrid mode, this point will comes inside the part body. Okay, hybrid mode means it both the geometrical set and sorry, both the geometrical element and a solid element will comes in a single part body. Okay, that is your hybrid mode, as you as the name is suggesting, hybrid. Okay, as we are doing the design in non-hybrid mode, so that's why uh, the geometrical element or surface element will comes in the geometrical set only. Okay, then comes to the line. Okay, in line also different types of line is there: point to point, point direction, angle, normal to curve, and tangent to curve, normal to surface. For basically this tangent to curve is used all the time. Then normal to surface, bisecting line. Okay, then the next reference element, it is plane. Okay, so you may use this option, offset from plane. So basically it is used to offset, means if you want to create any um, sketch or any geometry in a particular plane, that time you can go with this offset plane, and this offset plane is need, you can see it's need one reference and the offset value. Okay, let I will take this reference, this xy plane reference, and I'm just giving some dimension, let 50. Okay, and preview, you can see one plane is created with respect to this xy plane. Okay, you can go with the reverse direction also, and if you want to repeat after for multiple offset plane creation, you can check on the repeat. For that you after, okay, it will ask to you how many offset plane you want to create. Okay, let I want 5 offset plane I want to create. See, okay, and this offset plane is altogether comes in another geometrical set. As you notice, if you notice this one, just click on this and repeat, click OK. Here it will ask to you create a new body. To create a new body means one geometrical set will be created. So if I will check off this create a new body, it will all the plane it will comes in that geometrical set. If you want to create all the uh, offset plane in another geometrical set, you can create by using create a new body. Okay, so another important plane definition, it is normal to curve. Okay, normal to curve. So this one also one of the important one, so we will cover in this session. Okay, now we'll go to, this is all about the reference element. Okay, so I won't go for the deeply on this because it's already covered in part design. So I will go to this next one. Next wireframe design, it is your projection. Okay, so let me open. As you can see here, I have one surface and um, some wireframe like your curve and a line. Okay, I want to project this curve on this surface. Okay, how to project that one? Sometimes you want to project the um, curve or a line or a point on a particular surface. Okay, for that we have one option, that is your projection. Okay, so once I click on this projection, you will find there are two types of projection. One is a normal to normal. Normal means it is perpendicular to the surface. Okay, another is along with direction. Okay, we'll start with the normal. Okay, so Okay, so the first one is your normal. So here it will ask to you the projected. So which element you want to project? Okay, let I want to project in the middle one, this black one I want to project over this surface. Okay, so here it will ask to you the support where you want to make the projection. Okay, so I'm just click on this extrude one for the support, means I want to project this uh, curve over this surface. Okay, so it will ask to you the nearest solution and a smoothing like your tangency curvature, explore extrapolation mode, tangency and curvature. Okay, we'll go to the normal one now and see the what is the change. Okay, now you can see if I will go to the normal one, it will directly project over the surface. Okay, now I want to change with the nearest. I just check of the nearest solution. Okay, so the curve the curve shape slightly changed. Okay, if I want to go for the nearest solution, check on again the curve is slightly changed and I want the curvature. Okay, the smoothing should be curvature, there should not be um, any continuity, means point continuity or a tangent continuity. I want the curve should be perfectly cross sectioned. Okay, so that time I will go with the curvature continuity, and you can put the deviation like if means put the deviation means you can give the tolerance like 0.001 or as per your requirement, which one. If is 0.01 you want to put, you can put the tolerance. Okay, up to that we can make the deviation. Now preview. Okay, now you can see I'll just go to the extrapolation. In extrapolation you can see it is directly extrapolate, means it will increase the length of the element. Okay, so it will increase the length of the element in tangency mode. Okay, you can see previously the exact length it is projected over the surface. Now I have selected this tangency mode. It is taking the curve as a tangency continuity and make fully to the surface, support surface, and you can similarly you can go with the curvature. Okay, so like that you can perform the project operation with a normal option. Now I will go to the second types of projection type like along the direction. So here while click on this along the direction, it will ask to you the projected support same as the normal, and here the most important thing is it will ask to you the direction, in which direction you want to project on the project the curve over the surface. Okay, so for that, and remember one thing, this direction so slightly perpendicular to your surface. Okay, if it is not perpendicular, it will make some error. I'm just create, I want this time I want to project this blue curve and support same with my surface, and direction let I will go with this direction, this line. Okay, next direction, and you can see it will, if your projection is not possible, it will show you some topological error or a updated error. So here the diagnosis it is showing smart projection operation, two solution have the same maximum distance, use projection and select good result. So it here in this curve it is not possible. Okay, let I am trying with this. Okay, and you can see it is possible now. Okay, just hide this. Now you can see along with this line I have projected the curve, middle curve, and it is project over the surface. Same if you want to make it a tangency smoothing or curvature smoothing, you can go with the different types of smoothing, and extrapolation also you can make it. Extrapolation means it will increase the length of the curve with respect to the surface. Okay, then okay, so here though you can see I have projected one element. I want to project all the three elements. For that you have a group option. You can see in the projected element you have a group option, group. Okay, I'm just selecting two, one, and I want to project both. So at a time you can perform multiple projection. One means multiple curve as a projection. Okay, hope there is no doubts on this projection. So the next tool it is combined. Next tool it is combined. As you can see here, I have two profile, and these two profile is lies in two different plane. Okay, one profile is rectangle, another is circle. I want to create a surface by using these two profile. So it is not possible in our regular surfacing tools. For that, we can go with the combine. Okay, I want to create a curve by using these two wireframe element like yeah, as you can see the rectangle and circle. So I'm just click on the combine, and here also you will find two types of combine. One is your normal combine, another is your along with the direction. Okay, so if you remember this one, this combined solid in part design, there you will find also two profile with two different which is lies in two different plane, and there is one direction. Okay, so let's go with the normal combine and select the curve. Let it, this is rectangle is my first curve and this circle is my second curve, and I want the nearest solution. Okay, nearest solution preview. You can see the nearest solution is coming. I want the farthest solution, means which is far from the rectangle. Okay, I just check on this, check off and preview. We can see other side it is coming. Okay, so here it will ask to you near and far concept. Okay, I want to click on this, and I want near to this point. I want near to this point. Okay, near to this point means this first one, this one will create. Okay, if you want far from this point, then second one will become other side, the combined curve will be come. Okay, this is how we can create a combined curve by using two profile. Okay, now we'll go to the second type of combine, that is your along with direction. Okay, along with direction. So here it will ask to you first one, second one, and I want the direction will be this. Okay, first direction, and I want the second direction also this, and preview. So it is by along with the direction it is showing a straight line. The combined curve it is making a straight line. Okay, you can go with the different direction like y, and here also let check with y. Okay, okay, some error is coming. You can see along with the direction this second combined surface is coming, means combined curve is coming. Okay, is there any doubts on this combined curve?
No doubt, sir. No doubt.
Okay, so next one is your reflect line.
Sir, screen.
Screen is visible to you.
Yes, yes, yes.
Okay, okay, reflect line. Okay, I want to project this line over this ununiform surface. Okay, that time you can go with the reflect, And here you can see there are two types of reflect line, one is a cylinder, one is conic. Okay, so cylinder means the reflect line will comes in a cylinder shape, and the conic means the reflect line will comes in a conic shape. So here it is asking in support, one support, and the direction. Let's go with the x direction and preview. Okay, now you can see this one is projected or projected over the surface in cylindrical form. Okay, again, if you want to go the reflect line or to conic, here it will ask to you the support and the origin, want this origin, and here you can go with the angle, and here you can see this line, it is coming in a conic type. You can go with the normal or tangency as per your requirement. Tangency means it will go with the parallel, normal means it will go with 90-degree default, but you can change the angle of the reflect line. Preview. Okay, you can see this line is projected over this non-uniform surface. Okay, the next one is sealed out. Sealed out also you can find this this sealed out option in two types. One is your cylindrical, one is your conical. Okay, so let I'll go with the cylindrical. My element is this one. I want to project. For that I need some plane. I'm just create offset the plane reverse direction with 70. Okay, I want to place this sealed out edge with on this plane. Okay, for that just click on the sealed out cylindrical, element is this one, direction I will go with perpendicular direction, z direction, and the projected plane I want here. Okay, okay, it's coming, but I'm not check the right direction, believe. Okay, yes, you can see select it's a cylinder, but I want to project the cylinder over this reference plane. Can see the exact shape it is coming, means the cylinder outer shape it is coming. Okay, so outer shape it is in the rectangular form, so it is basically used to generate the outer edge of the surface. Okay, the sealed out definition means sealed out is generally used to get the outer edge of the surface. Okay, then the next one it is your parallel to curve. Okay, parallel to curve. Now if you want to create a curve which is parallel to the surface, okay, so there are different method. You can directly go to the plane, click on the plane, and click on the surface and create the sketch. Okay, or else you can directly in the You can create the parallel curve by using the parallel curve in generative shape design. So I'm just click on the curve and click on the support. Okay, so here it is asking to you the distance, you know which distance you want to create the parallel curve. Okay, so I'm just going to this preview. You can see the parallel curve is created here, or you can go with the reverse direction also for creating the parallel curve with respect to that selected spline. Okay, so here also you can find different types of parameters during geodetic, and here parallel corner type, sharp or round, smoothing. As I said, if you want to go with a non-smoothing, means it's a point continuity. If you want to go with a smoothing which is contains tangent continuity, that time you can go with the tangency continuity and curvature continuity. Okay, if you want to create both side of the parallel curve, you may check on this option also. Repeat object also you can go with. If you want to create multiple number of parallel curve, that time you can go with the repeat object after. Okay, then extrapolate up to support. Extrapolate means it will increase the size, means increase the length of the curve. Let's check with this. You can see the it is increase the length of the parallel curve, and it is taking support as the extrapolation preview. Okay, okay, in this way you can create, or you can generate the parallel curve with respect to your curve. Now next one, it is a rolling offset. Okay, rolling offset is nothing but to create a elongated hole. Okay, you may go for the sketcher for creating the elongated hole, or your you can directly create a elongated hole wireframe by using the rolling offset. Okay, let me try with this. I just hide all these things. Okay, okay, I will go with the this line. Okay, this geometrical set, a simple line. Go to this rolling curve. Here it will ask to you the curve and support, in which support you want. You want in xy plane. This is zx plane. Okay, let's try out this curve. Support is this, and you want a rolling curve here with the offset 2. Showing terminate. Oh, sorry, it's off.
Hello.
Yes, yes.
Sir, can you remove the upper one line is coming now, sir? That is Ecil Jyoti madam. Can you remove that, sir? We want big screen, sir, from your side.
Okay,
Those are not required, no, sir? So please.
we
Please increase your screen only, sir. Not required.
it's already in full screen actually.
Sir, which I am doing, are you seeing, na, sir?
No,
This is your system, na, sir? Can you apply this one, sir, once?
Just a second. You are showing something.
అయిపోదాకా వచ్చిందంట పहले आया ना फिर
Yes,
ओ
yes. You can share the screen. Hello.
हाँ सर
You want to show something?
ओके सर नथिंग सर प्लीज कैरी ये ऊपर का वो नहीं दिख रहा थोड़ा अच्छा से स्क्रीन दिखता है कैरी ऑन सर
Okay.
नॉन वीडियो फॉरेस्ट
Just a second. Okay. So we are here on rolling curve. Okay. Rolling offset. So I'm just click on the rolling offset, and here it will ask to you a curve. I'm just selecting the curve, and I want to give one support, and here, okay, support 1. Let the offset value is 0.5. Preview. You can see one elongated hole is created, means elongated shape is created over this. Okay, so without going to this sketcher, you can create the elongated hole by using the rolling offset. Similarly, here, without creating any, or without going to the sketcher, you can create the 3D curve by using the 3D curve offset. Okay, so I'm just hide this. Okay, I want to create a 3D curve. This, and I will go with the pulling direction. Let X as my pulling direction, and a radius or tension offset I will go with this. You can see directly I can create a 3D curve offset by using this 3D curve. Okay, just go to this. So it may be bit benefit when you will go for the airframe design, or when you want a exact length of a line, or any airframe design, that time you can go with this 3D curve offset. Okay, now the next one it is your circle. Okay, same in this circle also you can do by using the sketcher tools, but here you can directly go to the circle. Click on the circle. Here you need to define the point. Let I will define the point this, and I want to define the plane zx plane, and the radius you may define the radius. Okay, so by default it is taking the start degrees, means start angle and end angle. Okay, start angle it is 0, and end angle it is 180. Okay, or you can change the start angle and end angle as per your requirement, but if you want a whole circle, you can directly click on this. Automatic this whole circle will come to the picture. Similarly, you may have different types of circle for create inside the 3D. Okay, then the next one it is your corner. Okay, corner is nothing but to generate the circular circular shape or circular 3D element. Okay, so here just click on the corner. Okay, here you will find different types of corner. One is a 3D corner and corner on support. Okay, 3D corner means there should not be any support plane or support surface. Okay, let's try with the first one, corner. First element, just check with this. First element is this one, second element is this. Okay, and if I will go to the, and you need to define the radius here. Okay, you need to define the radius for corner value. Okay, as it will create a circular corner. That radius you need to define. Let the radius value I will define here for 50. Okay, and preview. You can see a corner is coming, but I want to remove, or I want to trim this corner, means all the unwanted element. Okay, except this and this, whatever the unwanted element is there, I want to remove. That's it is also available in this corner itself. Okay, you can go with the first element, trim first element, trim second element, and preview. Okay, you can see the unwanted element in 3D it is removed. And remember here, if you want to create any corner, that should be intersect to each other. Without intersection it won't create any corner. Okay, so again, this is the first solution. If you want to go for the next solution, you can see this this curve and this curve, it will create a corner. Preview. Okay, okay, this one and this one, except that whatever the thing, it is trimmed. Similarly, with the next solution, you can see this. Okay, and you, and the next type of corner, here it is corner on vertex. Okay, so if you click on the check on the corner on vertex, you need to select the element, first element. So it will take all, it will take the wireframe or take the curve as a single entity. Okay, you can see the sketch one have the sketch, in sketch one there are one two three four uh, corner vertex. Okay, here you can define the radius for making the corner. Okay, you may create this corner in your sketch environment also. Okay, but to reduce the time, you can go with this corner in generative shape design without changing or switching to sketch workbench. Then the next one, teacher corner on support. So I'm just click on the corner on support. Here it is asking the element corner on support. I need to check off this corner on vertex. Okay, so vertex, remember the profile should be in one sketch. Okay, if you want to generate the corner on vertex, for that we need a sketch profile. Okay, so corner on support, this is my first element and this is my second element, and I want to give a support. Okay, I want to give a support and you need to give the radius for creating the corner. Okay, now we can do the operation or operation like trim and split for generating the surface. Okay, this is how we can generate, means we can create the corner in 3D. Then the next one is your connecting curve. Okay, so connecting curve is generally used to connect two curve. Okay, so there are two types of connecting curve. One is your normal and one is your best curve. Okay, so I will go with the normal only. So this is my first point. Okay, and it is I need to give some continuity. Okay, which continuity I want, g1 continuity or point continuity, tangency continuity or curvature continuity, which one you want, you can define this here in the first curve. Okay, in the second curve, let take this point and this vertex point, and you can see the vertex point here also. I am giving the tangency continuity. Okay, but I, yes, so you can see I don't want this type of shape. Okay, I want this should be make the tangency mode. Okay, I just go to the reverse direction. Here also I want to go for the reverse direction, and in tension it will stretch by increasing the tension of the tension value. It will stretch, means it will track that curve. Okay, as per your requirement you can apply the value for creating this. And if you want to go for the trim element, you can go to the trim element, so that or these two will be joined together. Okay, this is how we can go for this connecting curve. Then here it is conic. The next tool is it is conic. Okay, so conic, if you remember in generative sorry, sketcher tools, for conic we need there are different types of conic, like if a 4 point, by using 4 point and one midpoint, or by using 5 point and one midpoint, we can create the conic. Similarly here in 3D also we can create the conic. Okay, so I'm just click on the start point. Okay, start point and the plane, let I will take this plane, and the end point here, the end point is this one. Tangency point, I want to make the tangency point, let this. Okay, start and end tangency. You can see one conic is created with in the support plane xy. Okay, what I selected, I selected the start point and the end point, and the start point is making tangency with the line 1, and the end point is making tangency with the line 2. Okay, you can define the target intersection point where you want to create, up to what you want to create the conic, you can give the target intersection point. Okay, I'm just click on this. You can see up to this I want to create the conic. Okay, you can define the parameter, or you can of this parameter, sorry, you can define the parameter 0.1 or 0.9 for getting the conic of the, by using two curve. Okay, this way you can uh, create the conic by using the wireframe design. Okay, the next one it is your curve, helix, spiral, spline, contour, isoparametric curve. Go with one by one. First one it is your spline. Okay, so for spline we need point. Okay, you can create a point inside the spline, or you can generate the point. Just hiding this geometrical set and insert another geometrical set for demonstrate this spline. Okay, I'm just creating plane a point in three different plane: yz plane, another point, xy plane, another point. Okay, now I want to create a spline by connecting these 3 points. Okay, it is similar with the sketch spline. For that we have some point. I'm just click on the first point, second point, and third point. Okay, you can see by using these 3 point it is creating a spline. Or if you want to create a closed spline, you can go with the close and it will create a closed spline. Preview. Okay, in this way you can create the spline in generative shape design. Okay, then the next one is your helix. Okay, so as you can see, for a helix there are three types of a helix. One is means type of a helix. One is pitch and revolution, height and pitch, height and revolution. Okay, so for that I have one input data. Okay, I want to create the helix by using this wireframe design. Okay, click on the helix and I will go with the pitch and the revolution. Okay, pitch means the height of between two helix curve, and the revolution, how many revolution you want. Okay, here it is asking to you the starting point. Okay, here it is asking to you the starting point. Later, this is my starting point. Okay, this is the starting point and I want to revolute on this axis. Okay, now you can see the pitch is 1 and the revolution is 1. Now one revolution, that's why the one curve is generated. If I will go with 2 revolution, 3 revolution, or I will go with 10 revolution. Okay, you can see 10 revolution is coming, but the piece size is very small, 1. You can increase the piece size. Okay, you can give the clockwise or anti-clockwise direction for generating this helix. Okay, now okay, now I want to create the helix with respect to this profile. I want to create the helix like with respect to this profile. For that you need to click on the profile and select the profile, so that the helix will create with respect to the profile and the cross section. Okay, profile cross section. Okay, if you increase this one pitch, you can see pitch or revolution with respect to profile, it is creating the helix. Okay, you can go with the counterclockwise or clockwise direction for the of the helix. Again, if you want to create the taper angle, see, you can see the taper angle inward, it is inward. If you want to go with the outward, you can see taper angle 12, it is creating outward. In this way you can create the helix with different option. Here is also the variable pitch. You can define the helix. Reverse direction also you can put. Preview. Okay, is there any doubts on this? See, it's a online session, so you may have
No,
some
sir.
doubts. Okay, up to now there is no doubt, so we'll go for the next one, the spiral one. Okay, so as you can see in the helix, we are generating the helix in with respect to a profile. Okay, spiral one, it will create the spiral curve with respect to a support plane or support curve, a support surface. Okay, so let's go with that one. Okay, for a spiral you need a point, you need a center point for creating the spiral. Okay, helix, the difference between helix and spiral is helix will um, take the reference of the axis, but the spiral one, it will take the reference of the surface or the plane, reference plane. So I'm just click on this spiral curve. Here it is acting a support. and the center point. Okay, and the direction, in which direction you want to do. So let I will go with the x direction, and the radius, start radius, it is 0, let it is 0, or you can give the orientation counterclockwise or clockwise, angle and radius. So radius I want to change to 5. You can see while going to the 5 the radius is changed, and you can give the revolution. If you increase the end radius, you can see you can create the spiral by using this spiral option. Okay, for spiral what you need a support point and a direction. But direction you will give, but you each need a support and point. Okay, then the next one it is your spline. Spine. Spine is basically we is used for creating the spline. Okay, with respect to the multiple number of plane. Okay, as you can see the icon of the spine, you can see the icon of the sign, it is showing a guide curve and a planes. So I'm just click on this. Here I need to select the start point. Here I need to select the start point where I want to create the spine, and I need to select the plane in which the spline is created. You can see you can see the spline is created in with respect to multiple number of plane. Okay, reverse direction also you can put. In the reverse direction it is going with a very long, but okay. Here you also you can go with the compute the start point preview. Okay, so in this way by using the different plane we can create the spline default in in a wireframe design. The next one is your conquer. Okay, sometimes just assume sometimes you have created you have created a surface, but in over that surface you have create some sketch like line or a wireframe design, some sketch. Okay, you can see there are three sketch is available here, means is three geometrical line 1, line 2, sorry, line 2, line 3 and line 4. Again it has point 3, 4, 5. I don't you don't want to put this thing as separately. You want to put in a single sketch. Okay, that time one option is there, conquer. For that the requirement is you should have a support. Okay, on this. Okay, if the wireframe element or reference element is create over any support, that time you can go with the conquer for create for changing or modify the reference element to a single element. Okay, I'm just selecting the surface and the curve, and remember the first curve which you have selected, that will be the conquer um, reference. Okay, so line 1 is my first reference, second one, third. Okay, now if I'll go to the preview, and okay, you can see conquer, it's a single entity. Okay, single profile right now. Okay, if I will hide all this thing, if I will hide to line 4, or conquer will be hide. Why? Because it is taking the reference as line 4. Okay, line 4, by using the line 4 we are making the line means conquer to extrapolate the length of a length 2 and length 3. Okay, now we can perform the operation, whatever the operation you need in surface. Okay, Then the next one is a isoparametric curve. So this isoparametric curve also very important. If suppose if you have a irregular surface, okay, like this. If you have a irregular surface and you want to project some, you want to project a curve, that is not possible in this case. Why? Because it's not uniform cross section. Okay, that time you cannot use this also projected element like your projection, then your reflect line you cannot use because it is a irregular surface. That time you can go with the isoparametric curve. Okay, you can directly go for this isoparametric curve and place above the surface. So automatically you can see there is no surface. Okay, go to the isoparametric curve. Above this I can select the, you can see here it is coming way curve. You can drag to the end point also. Similarly, okay, like that you can project the surface, means project the curve on a irregular surface or a freestyle surface by using the isoparametric curve. Okay, the next one is curve from equation. So for that you may create some law or some equation for creating the curve. So right now I don't have any example to show you. Mm, but equation means like let x is equal to 20 and y equal to 20, also 25, z equal to 30. So we'll make some equation by creating the law so that the curve will generate according to the equation. Okay, this is all about wireframe design. Is there any doubts on this segment wireframe?
No, sir.
Okay,
Okay,
so we'll take some break for 5 to 10 minutes.
okay, sir.
Then after we will start the real surface. Okay,
Okay,
okay.
okay,
So
okay.
we'll get back exactly 11:45.
11:45.
Okay,
Okay, sir.
okay. To limit and middle. Okay, so okay, for that I need a two line as it is a linear. Okay, let I will hide all these things. Okay, now I will create the sweep or generate the sweep by using the two limit. Okay, let this is my first guide curve and second guide curve and preview. Okay, I'm just defining this one. First guide curve, second guide curve and preview. You can see length is, I can generate the surface by using the two guide curve with the two orientation. Okay, so by default it is taking the first sweep end and second sweep end to cutting the surface. Okay, so in this way you can create the surface by using the linear element. Again, if you want to go for the limit and middle, so the second guide curve as it take as will take as the middle. So I'm just click on this. You can see the second guide curve is taking the middle profile. Okay, so here if you calculate the distance from the second guide curve, the first guide curve surface, and the first second guide curve, the end point of the surface, or maximum edge of the surface, the distance will be same. By using this, you can, by using the limit and middle also, you can go with the sweep. Then the next type of sweep, it is your, means same the with linear profile. Subtype it is with reference surface. So what it is asking, it is asking a guide curve, reference surface, and angle. Okay, length, let 40, 42. Okay, now the angle I have defined, and again I have defined the length 1 and length 2. Length 2, if you want to define the length 2 also, you can define the length 2 for creating the sweep. Let I will define only the length 1 and see. Okay, again here also you can find the angular sector. So angular sector is nothing but the first angle, the angular value. Second sector, it is your negative angle value. Third one, it is 180 plus angle value. Fourth one, it is 180 minus angle value. Okay, you can check this one. Fourth, this will be the 180 minus angle value. Total it will be 180 minus angle value. The angle will be created, means the surface will be created. Okay. Now the next type of one is here with reference curve. With reference curve also you can get this one, two guide curve, one guide curve and one reference guide curve. Okay, here you can define the angle and the length also. Okay, for that you need to select the first guide curve and the reference curve for to generate the surface. Then the next one with the draft direction, it is also a important one. Draft direction, it is basically used to create a high quality surface. Okay, this draft direction surface or sweep is used to create a high quality surface. Here in this draft direction, you can find wholly defined G1 continuity location value. Okay, so here you can find the length type. So previously we are getting only one length type, but here you can get different types of length type, and you can define the length dimension. Okay, you may try this one. And the next one is here with the two tangency. This is also quite interesting. Just open that one with the two tangency. Okay, if you have a, if you have two surface, two curved surface, okay, and you want to connect with another surface which is tangent to that particular two surface. Okay, you can see here it is a two surface, means two circular surface, or you can say the conic surface. Okay, I want to make connected these two surface. So for that you have one option, that is with two tangency surface. Okay, your spline need to be uh, give this time, this your spline should be parallel to each other, means you can give x or y, it should not be perpendicular. So I'm just giving y. Okay, the first tangency surface, second tangency surface, preview. Okay, preview. Okay, means the surface is generated with respect to x axis, and the first tangency surface is this one, second tangency surface is this one. You can see while creating it is connected to these two tangency surface. Okay, but you don't want to generate this one, you want to remove this one. For that, what you need to do in this sweep, we have one option is trimmed first element, first tangency surface, second tangency surface. As you can see, the solution it is only one. There is no other solution or any angular sector. No angle is involved in this type of sweep. So preview. Okay. Okay. You can see the surface is generated by using two tangency surface. Okay. Now here also you can find the circular by using the circular profile. So let's go with this conic. This may be useful because when you are creating the surface, you may take some guide curve. So by using two guide curve, by using three guide curve, four guide curve, five guide curve, how we will generate the surface or how we will create the surface, we will see directly in this sweep with respect to conic profile. Okay. Okay. So I'm just click on this sweep and the sub type profile type it is your using conical profile. Okay, conic profile. Here I am selecting the first option, two guide curve. Okay, so as you can see in this swept surface definition, the subtype it is two guide curve and the first guide it is asking to you the first guide curve and tangency. Remember, if tangency is there means you should have the surface. Okay, if you want to connect two surface by using two guide curve, you may create that one by using this sweep. Okay, conic sweep. So let this is my first guide curve. Okay, so this first guide curve should be tangency with the first surface. Yes, then the second one, second guide curve, and the second guide curve should be tangential with the second surface. Okay, the parameters angle is there. You can define the angle and parameters. Okay, guide curve also you can define. Just see preview. Okay, okay. Sorry, I need to define this one. Click on the surface, first guide curve, surface tangent, and preview. You can see the the surface is generated with respect to two guide curve. Okay, similarly I can go with the three guide curve. With three guide curve means it should be passed through three guide curve. So as you can see, the guide curve one, it is asking a guide curve one with tangency means it should have a surface. The first guide curve and the tangency, second guide curve also with the tangency. Okay, second guide curve does not have the tangency, so I need to give the second guide curve, and third guide curve or last guide curve have the tangency. You need to define properly for creating the surface by using the sweep with three guide curve. Preview. Okay, you can see the surface is generated with respect to three guide curve. Okay, then you can define the guide curve by use means you can create the surface by using four guide and five guide curve. You can see here there are four guide curve, and remember this guide curve should be follow one isoparametric or curve, or it should be follow a continuous. It should be meet the tangency or curvature continuity. Just click on the thing. Here I will go with the four guide curve. So this is my first. Okay, in the four guide curve it is asking a curve which should have the tangency. Okay, I should have the tangency. Second, third, fourth. Preview. Okay, you can see the surface is generated by using the four guide curve. Again, if you want to do with the five guide curve, Let I will take this one first, second, third, fourth, and five. Sorry, five. You can see the surface. Okay, should be select the surface curve properly. You can see by using the three guide curve, I have created the surface. In this way, you can create the surface by using the sweep profile. Is there any doubts on this 21 types of sweep?
Okay, okay, sir.
Okay, the next one it is your adaptive sweep. So it is also a very important one. Adaptive sweep. Okay, you can see I have a profile, I have two guide curve, and this is one combined. Okay, so I want to create the profile which have different cross section. So you may create this thing by using the multi section, but some error will come because it is creating in the combined curve. So I will go with this. We have one option that additive. So your guide curve, you need to select the guide curve first. Spline, I want this surface. I want this. Okay, surface should be mean, and here sketch this one. Here it is taking consideration of the point. Okay, you can add the point also, different point for changing the dimension of the surface. See, in every orientation it has creating this point, and here you will find the parameters and the user selection. Here in user one you can define the length and angle of surface creation. Okay, let's keep with all this thing with 85. Okay, you can change that one also by according to your requirement. You can see the surface is generated with that value of this. Okay, I have not selected the last point, so I need to select the last point also for creating the surface. Okay, so like that you can create the additive sweep which has different cross section, and you can manipulate the cross section value by using the option. Okay, then we have fill. Okay, so fill is nothing but to fill the wireframe. Okay, so just open the fill. Okay, I want to fill this wireframe. Okay, I have created one some reference wireframe. I want to fill this one. So how to that go to fill? You just go to this fill option, select the outer boundary and preview. We can see it is fill, but I want to remove the inner boundary. Okay, I want to remove these two hole. Okay, again for that we need to define the inner value, inner boundary, first one and second one, preview. You can see I'm remove directly from the surface. I have not used any trim or split option to remove these two. Okay, by directly I can go for the fill and remove the option. Again, I want to I want to pass this fill with this 3 point. Okay, so you can pass also by using the point or curve also. Okay, preview. Okay, you can see the fill is performed and passing through this 3 point. Okay, you can pass through this sketch also. Okay, in this way you can create the fill. Then the next one is multi section. This is very important. because most of the time you maybe use the sweep and multi section. Okay, so just okay this one. So what is multi section? So multi section surface can be created a sweeping operation, but this time we will use one or more section along with the curve, defaulted code. So I'm just hiding this one. First we'll see this one, how we are generating the multi section. Just click on this multi section. This is my first profile, this is my second profile, and third profile. Remember, this multi section is I can use the open profile, but uh, in your part design I cannot use the multi section that section surface or profile which is open profile. In that time you should have the closed profile, but in surface you can work on open profile also. Okay, that time means if you will create the multi section in solid, that time your profile should be closed. Okay, you can see I have selected three multi section sketch which is lies in three different orientation. Okay, and remember, whenever we will create the multi section, the arrow mark should be same direction, and you can see preview. Okay, automatic one computed spline is generated to create the multi section, and you can see I have 1 point, 2 point, 3 point, and 4 point, and I have means here it is generated some edge 1 2 3 4. I don't want to create this type of a edge. I want the surface should be edge in isoparametric form, should be continuous. Okay, that time what you need to do is you need to define the guide curve, or um, or you can go with the vertex. Okay, so vertex is nothing but, so here the important thing is coupling. Okay, we need to give the coupling for generating the surface to get the isoparametric surface. So basically coupling is compute the distribution of isoparameter of the surface. Okay, so as you can see there are 4 point is available, so I can go with the vertex to create the coupling. Okay, so here I'm just click on the first point, sorry, add coupling, first point, second point, and third point. You can see automatic curve is generated. The second point means the second point also I am creating another coupling. This point also. Okay, there are 5 coupling is available. Now you will get the 5 curve only. Means the profile is refined. Means the surface is now isoparametric. Then the next one,
Sir,
yes.
sir, we have lunch exactly on 1 o'clock, sir. So we need to leave from here before 15 minutes, sir.
Okay.
Because some distance is there to canteen, so that's why.
Okay, we will complete this multi-section, and after launch we will complete all this thing and we will go for the sheet metal design. Sheet metal
Right.
design it will take 1 2 hours only, not more
Okay,
than
sir.
that.
No. After lunch. After lunch.
After
Okay.
launch only, yes.
Okay. Okay.
So here multi-section with respect to guide curve. Okay, that time we means the previous one I have used in coupling with vertex. Now here I'm selecting this first curve, second curve, and this time I will give the guide curve. This is my first guide curve, second and third and fourth. If you have same number of guide curve, you can go with the ratio, tangency or tangency, then curvature. Preview. Okay. Okay. I'll go with this. Okay. Why it is coming? Check. Multi-section. First one, first direction, second direction. Okay. You need to give the direction properly. Okay. Both the profiles should have same direction. And the guide curve. First one, second, third and fourth. Preview. You can see. By using the guide curve, we can define the multi-section surface. Again, in coupling also you can go with the tangency or type or tangency then curvature. If you have this option will only activated when you have same number of vertex point, okay, or a guide curve, same number of guide curve. Okay, that time you can perform, we can generate the surface with the tangency and tangency plus curvature. Okay. So 5 minutes is there. We can cover this blend also. Hello.
Yeah, yeah, okay, sir.
Okay, we can cover this blend. Then after that, we will go with operational and transformation feature in a second half. So blend operation. Now you can see there are three types of blend. Okay, means one is basic blend. So why we are using the blend? Blend is generally used to create the profile in two curve. Okay, so I will create a, okay, I have two surface right now. Okay, I want to create a blend. I want to match these two surface by using the blend. Okay, these two surface has a different orientation. I am selecting the profile, means this curve and the support, the first second curve and support, and you can see it is generating the, it is generating the surface. Okay, I want to remove this one. So for that, what you need to do is trim the first support. Okay, here again you have the tension. So if I increase the tension 2.5, you can see it is dragging that side. If I will increase the tension of the second element, it will push there. Okay, first element trim, you can see the surface is generated trim with respect to the surface, developed surface. Now the second one is coupling, similar with the multi-section. Now I have two surface, two curve. Remember this direction should be same, and here I need to give the coupling point. So if I will go to the directly, I will go to directly blend first one and second one. Okay, it is creating some irregular surface. It is not isoparametric. Okay, if I will go to this coupling, first point, second point, it's making the coupling, first one, second one. So four edge will come as we have four coupling. Preview. Okay, now the surface, it means this blend is create smoothly. Then next one is your close concur. So I want to create a coupling by using these two profile, means create a surface. So this is my first one and second one. And here you can see the first point and second point is different. And if I'll go to the preview, it is making a twisting surface. If I will change this point, first point to here, let I will change this first point to here, okay, to refine the surface. I can able to generate the perfect surface by using the closing point. Okay, so for creating the perfect shape, you need to take care of this method. You may use sweep, multi-section or blend as per your requirement. Which one will be better for generating the surface? You can go with the surface generation. Hope there is no doubts on this surface generation.
Okay, sir. No doubt, sir.
Okay. So after launch, we will cover this operational toolbar and transformation toolbar. Then we will directly go for the generative sheet metal design.
Okay.
Okay.
Sir, we will start by 2 o'clock, na, sir?
Yes, we can start by 2 o'clock.
Okay, sir. Thank
Okay.
you. Yeah.
Let me share my screen. Is my screen visible to all? Hello.
Yeah, visible, sir.
Okay.
Continue, sir.
Okay. Up to now, we have completed wireframe design and surface generation. Now, this one is operational toolbar. Okay. After creating the wireframe and surface generation, we need to refine the surface. Okay. So, I'll just start with the operational. The first one is join. Okay. Why you are using this join? As you can see, sweep 1 is one surface and extract is one surface. Our aim is to make it one surface. Yes or no? So for that we need to join this surface for making solid one. Okay. This surface need to be joined because we need to create a solid one. If it is a single surface, then only solid is possible. If it is some segment surface, then solid won't be possible. It will take a single solid. It will take multiple solid if you have multiple number of surface. Okay, so I'm just clicking on the join. Okay, as you can see, sweep one and extract one have two surface. I'm just click on the first surface. You may select by you manually by select manually, press Ctrl and select the two surface, or else you should go to this join, select the first surface and go to the right click on the sweep or first element and distance propagation. Whichever the part or surface is connected to the first element, it will come automatically to that element to join. Okay, there you will find the heal, cell, merge or ignore the error element, simplify the result. And remember, whenever you will join the component or join the surface, you should check this connectivity and manifold. Okay, manifold means if some twisted movement will be there, then it won't go for the joining process. Connectivity also some gap also there, or if it is not connected properly, then it will show you some error. Okay, you may check off this check tangency, because sometimes our surface not following the tangency continuity, but sometimes but every time it will connect to with the point. Okay, point continuity. So you may check this one and preview. You can see now These two surface is connected together and it is creating a single surface. Okay, in this way we can perform the join operation. Okay, now the next one is, okay, we will see this thing later. We will directly go to this split and trim. Okay, I'm just open split. Remember, we can split the element, geometrical element like point, line or surface by using these tools. Okay, it may be the point. If point is there, there should be a curve, then only split is possible. Okay, now I want to make split this element. Okay, this curve one, I want to split with respect to this point. Okay, is it possible or not? Yes, it is possible. You just click on the split, and here after click the split, it will ask to you the element to cut, which element you want to make split. Okay, so I want to make split on this element, this curve to spline. Okay, the total element with respect to this point. So after that, split means it will cut this spline or curve into two parts with respect to that point. Okay, you can say, you can see here it is given one option other side, which side you want to keep and which side you want to remove, you can give your. Now you can see one side it is coming, or if you want to keep both the side, you can uh, check on this option, keep both the side preview. Okay, you can see previously the split to curve is a one curve, now it is a two curve. This is one curve and this is another curve. You can see one curve and this is another curve. Okay, this is how we can create, means how we are splitting the element with respect to point. Now can we split these two element by this two curve? Yes, we can split. You can go with the split. I want to cut this element with respect to this, and remember, for that we should the two elements should be intersect each other. We'll go for the other side. You can see the splitting element is done. Okay, if you want to keep both the side, you can check on this book, keep both the side. So both the side will become, means this is one of the curve, another curve. Okay, like that we can split the curve with respect to curve and curve with respect to point. Now I want to split, let I will create one of the plane. Okay, I will create one of the plane. Okay, I want to split this surface with respect to plane. So what I need to do is I'll create one of the, okay, cutting element, cutting plane. Okay, I will do one thing. I will create one. Okay.
Okay.
Okay, now I want to split this one with respect to this cutting surface. Okay, so what you need to do is you just go to the split element to cut. This one I want to cut with respect to this. You can see one side it is removed. You can go with the other side also for splitting the surface. So here we had seen the splitting with respect to point, splitting with respect to curve, splitting with respect to surface. Okay, similarly we can do the splitting by using the plane also. Okay, the next tool it is trim. So I'm just going to open trim option. So what is the difference between split and trim? So when you will go for the split, it is not joining to surface, but in trim both the surface will join together and at a time two operation will be performed. Now I will go to this trim option. My first surface is this and second surface is this. You can see here it is giving one two option. One is other side next element, other side previous element. Okay, and remember whenever you are applying the trim, it will join two surface automatically. Okay, just okay, this side I want to remove and the top one I want to remove this. Yes, you can see it is trim the element. And this one, if I will hide this one, it is a complete one surface. I'm not I won't use any join for perform the um, perform to join the two surface. Okay, so again if I will go with the split, here you can understand the split. I want to cut this surface with respect to this. Okay, so you can see this surface inside surface is trimmed. Okay, now we can see, sorry, split. You can see trim one and split one is two different surface. If similar operation I can do in trim, in that condition these two surface will be one. Okay, if I will do the same operation by using trim. Okay, same operation by using trim, you can see it will convert to one surface only. This is my first surface, this is my second surface. Okay, okay, I want this here also. I want the top surface. You can see I won't go for any other operation or a joining operation for make it one surface. Okay, this is how we are using the trim. Then now I can use the edge fillet over this. So edge fillet is similar to your part design. Let the radius is 1. Okay, here the radius is very small. I'm going with 0.3. You can see I have I perform the edge fillet also. Okay, similarly, uh, so when I will go for the edge fillet, it will ask to you the constant and variable. Then here blend corner also you will find. Variable means it won't go with a uniform cross section or a uniform fillet. Okay, this is how we can perform the trim and split and edge fillet. Now the next one is boundary. Okay, now I want to create a boundary of this profile. Okay, so when I will click on the boundary, you can see it is asking to you the propagation. One is complete boundary, one is point continuity, one is tangency continuity, and no propagation. We'll see one by one. If I will click on the no propagation and select one of the boundary, it is selecting on the particular edge. It is not going with the other edge. If I will select the same, you can see only this edge is extracted. Okay, if I will go with the point continuity, you can see whatever the edge is connected with the point, it is taking all these thing as a boundary condition. Okay, then if you will go with the tangency continuity, you can see in this edge only this edge is having the tangency, making tangency with the edge. That's why this only this person is taking as the tangency continuity as a boundary. Okay, if I'll go with the complete boundary, you can see complete boundary means it is taking the point continuity as well as inside the part also it is coming the boundary. Okay, here you can give the near or far or keep all element. Okay, you can see the boundary has been defined. Now now we'll see boundary with the limit. I'm just click on the boundary. I'm selecting the surface edge. I will select this surface edge and I will go with the point continuity. Point continuity, understand, which the edge which is connected with respect to point. As you can see, it means this edge is connected with the point. Here also it is connecting the point everywhere it is connecting the point. That's why it's taking the point continuity. Okay, I want the limit. I want a boundary limit up to first limit point, second limit point. Okay, I want only this much of a boundary. For that you can select the limit, or if you change the direction, the other side will take the boundary. Preview. Okay, so this is how we can perform the boundary operation. Okay, then the next one is here extract. If you want to extract the specific surface from any solid part or any a surface, that condition you can go with the extract. Let I will extract this one. Okay, as you can see here also you will have the propagation type. Okay, one is no propagation, means only selection. Then point continuity. Point continuity means whatever the parts or whatever the surface is connected with the point, it will comes as the mean it will be selected. Then tangency continuity, you can see only this surface is, I have selected this one, only this surface is making tangency with the surface. That's why only this one is coming. Then curvature continuity, here it is not making the curvature continuity, so it's not taking the curvature one. Similarly, the selection one, depression also. Depression means it will forcefully taking the extract. Okay, preview. Okay, you can see one extract surface is generated about the surface. Okay, similarly you can go with the multiple extract. Okay, this is how we can perform boundary extract and multiple extract. Then okay, then we will see some dress of features like fillet. Okay, so I'll go with the simply fillet. Okay, this one. Now you can see here about the difference. Here you can see the difference between say fillet and edge fillet. Okay, here you can see these two surface is intersecting each other and it is not joined yet. You can see extrude 2 is a separate surface and multi-section is a separate surface. So if you want to make it one surface or by using the shape fillet, here you have the shape option, first one, second one. You can see it is taking the trim. If you want to change this direction, automatic it is generating the, means it is connecting the surface. Here also I need to change the direction. You can see automatic it is remove the unwanted element, and it is making uh, say fillet. It is applying the fillet also. Okay, same thing we can do it by using the trim operation. Means after trim or after split we need to go for the edge fillet. Okay, edge fillet is not possible if it is not connected with the, if the two surface is not connect each other. Okay, as you can see these two surfaces each intersect each other. So for that I need to go for the split. First element, second element, I want other side. Okay, again I need to go for split, this one, and need other side. Now you can see these two split has two different surface. Here I need to apply the edge fillet. So here I need to apply edge fillet. Okay, so before creating the edge fillet we need to join two surface. So go for the edge fillet and you need to select the edge for applying the fillet. Let the fillet dimension is 5, and you can see I can apply the fillet. So as I said, edge fillet is not possible if it the surface have different cross section. Means the surface are individual surface. If uh, it is a joint surface, then only edge fillet is possible. Similarly, there are face to face fillet and a tritangent fillet. Let's check with the face to face fillet. Okay, so I want to make a fillet between this face and this face. Okay, for that what you need to do is you just go to this face to face fillet, select the first face, second face, and you can make the radius, give the radius value and preview. You can see it is chamfering, means it is removing the element by um, it is creating the surface by removing the other one. Preview. Okay, you can see here you can create the face to face fillet like this. Then the next one is tritangent fillet. Tritangent fillet, for here what do you need, you need two surface and one surface which you want to remove. So I want these two surface for the face to fillet and the face to be removed, this one. So preview. Okay, it is similar with your 3D part design. Okay, then the next one is your, here it is extrapolate. So as I already explained to you, extrapolate means it will increase the size of the curve or surface. Okay, I'm just creating the extrapolate. I want this one to be extrapolate with respect to this. Up to the element. Just I want to extrapolate this edge. You can see 40, it is extrapolate. If you want to increase the surface or edge of the surface, you can extrapolate. You can select multiple number of a boundary also. I want this also, this to be extrapolate. I want this also for extrapolate. Again, if you want to increase this, you can make extrapolate by using the extrapolate option. Okay, here you can define the length or up to the element also. So there is no element, so I'm just giving the length. Okay, similarly we can extrapolate the, can extrapolate the curve. Okay, this one I want to extrapolate. Now in this time I have the element. Okay, I will select the element up to this, sorry, up to this edge. You can see I can extrapolate the curve up to this edge. Similarly, in other side also I can extrapolate the one up to this. Okay, so like that we can extrapolate the curve as well as surface. Then the most important thing is here, it is healing function. So what is healing? So basically whenever you will go for the join, I'm just now I have three surface. You can see I have three surface and it has some gap. Okay, it has some gap. If I will go for joining, is it possible to join? See, if I will go for join, it is showing some error. Non-context result count 3 domain. If you want to display the diagnosis, click yes. Take some time to for display. So you can see here it is showing some gap. Okay. So for that you can directly go for healing function. So I'm just selecting this one. I want to give the merging distance. Let 0.05. Okay. Okay, 0.5 and preview. You can see this surface is joined, but the question is how I know how I could know this merging distance. Okay, that proper value. For that we cannot give this merging distance value as for your means by your own. We need to calculate this merging, means this gap, we need to calculate this gap. For that what you need to do is you just go to this analysis, connect analysis. You can see here connect checker analysis. Okay, you just click on this and I want to select, I want to know the gap between this and this. Okay, and you can see automatic it is taking the surface, three surface is taking. And here g0 continuity, g0 continuity means it is a point continuity. G1 continuity it means tangency continuity, and g2 continuity means it is a curvature continuity. G3 means it is a tangency plus curvature continuity. Okay, as you can see g0 continuity it is showing 0.2, means it has some gap of value 0.2. That's why it is not maintaining the point continuity. And g1 continuity means it has the differ value 118.644 degree, means it also not maintaining the tangency continuity. So what you need to do is for making a heel or making join, we need means there is 0.2 gap, 0.2 gap. So we need to give the healing function, the merging distance should be 0.2, then only it will make a complete surface. Now you can see the gap is filled. Okay, you can give more than 0.2, but that time it will create some manifold. Okay, if you try to give this merging distance 0.1, you can see some gap will be there, some error will come. You can see the deviation is 0.071. So you should take care of the healing emerging distance by check the gap, and the perfect value you can apply the merging distance. Okay, is there any doubts on this healing and connect checker? Because it's very important. Some you will face this problem many times in generative self design. Hello.
Sir, no doubt, sir. Please continue, sir. If you have any doubt, please ask.
Okay,
Please continue, sir.
okay, okay, fine. Okay, the next one is smooth curve. So as I said, for if you are creating any curve, then you will find some point. Okay, inside that, if you it is a point continuity. For making in tangency and curvature continuity, you need to go for smooth curve. Okay, it is basically used in to mold and tool design, tools design. Then here it is surface simplification. This is very very important. Sometimes you are getting the input value in the form of a class A surface. Okay, so let you can see you will get this type of surface from it's a isolated surface. You can see in that surface lot of surface are involved. You can see here 1 2 3 4, like all these are involved. If you want to make it a simplified surface, for that what you need to do is you just go to this surface simplification, select the face to merge and preview, and okay, just a second, it's not the one. Just go to the surface, select the surface, preview, and okay, you can see the surface is refined now. It is very clear, and whatever the surface is not now, you can cut it from there and create your own surface again. Okay, this is how the surface simplification is work. Okay, the next one is your on trim. Let I will go with the on trim or a restore. Now you can see here I have a split surface. I know my original surface is something there. Okay, I want to recall the restore that split surface, means the original one. For that, what you need to do is you just go to the untrim. Okay, click on the split. So after click OK, it will take to you the original one, the multi section. Okay, means it is basically used to restore the original surface. Okay, you can see. Now the next one is your disassemble. The extrude one, it is a one surface. I want to disassemble the with respect to this edge, two edge. So if I will disassemble this surface as with respect to these two edge, then you will find three surface. You can see 1 2 3. Okay, for that what you need to do is you just go to the disassemble, and here you can see in the disassemble mode. Okay, I'm just selecting this one. It will directly say you how many parts, means how many element it will disassemble. You can go with the domain only. Domain means that only for isolated one, or you can go with the disassemble with 3 1. Can go with the these three element. Okay, three cell. Okay, you can see 1 2 3 surface is coming. Okay, 1 2 3, or else you can go with the disassemble with the domain one. Select that one, only domain one will come, and this should come in isolated one, so that you can share the your geometry to anyone else without showing the history of your work. Okay, this is how we can do the operation in generative shape design. And one of the most important one feature, it is feature draft angle. So I'm just creating and just create oh, two profile, so that you can understand what is the draft angle, how we are calculating the draft angle. Okay, this is the first one. same. Okay, now I want to see the draft. Just click on this. So it is asking to switch in material mode. In material mode only draft angle possible. So I'm just selecting this one. Here you can see here the draft which is less than 0, it will show in blue color. The draft between 0 to 2, it will show in uh, a red color, and the draft will above or 2 degree, it will show in green color. Similarly, if I will select this one, you can see the color difference. So the draft, you can go to this display compass. Here the draft angle, it is minus 60, minus 46.31 degree. Okay, means it is less than 0. That's why it is coming in blue color. Similarly, here in this red, it is coming in, yes, it is coming in 1.448 degree. That's why it's coming, means it is in between 0 to 2 degree. That's why the color it is uh, red, and above 2 degree it is coming in green. Again, you can go with the mode of view. You can see the change, the draft angle, you can see according to your requirement. Okay, in this way you can calculate the draft angle and see the draft angle. It is basically required when you will use in core and cavity separation. So this is all about generative shape design. If you have any doubts on generative shape design, you can ask, or else we can switch to generative sheet metal design.
So can you take any model, anything like component? Can you show the what are the commands you are now using for the process? For example?
For what means, which type of model you want?
Aerospace, any aerospace component engine or
Right now, I don't have this aerospace component. I will share to you the input data. You can practice. Okay.
okay.
Okay. So if you don't have any doubts on the generative sheet metal, sorry, generative shape design, then we can switch to sheet metal design.
Okay, sir. Please.
Okay. So before going to the sheet metal design, we need to understand that why we are using the sheet metal design. Okay, generally whatever the operation you are doing in part design and surface design, that operation we will skip in sheet metal design. Okay, it is just like a industrial part. Okay, directly we will click the edge, it will directly create a band or wall. Okay, like band, cutout, stamp, flange, we can directly create by click a single. Okay, just click in a single click, we can create bend like structure, cutout, view, and cut, stamp, flange, everything. So there are many process of sheet metal like blanking, drawing, deep drawing, blending, folding, punching, forming, stamping, searing, shielding, etc. But the advantages of this generation of new part by using the sheet metal design is it will give you a high productivity. The error will be very minimal when you will use this sheet metal design, because it will take a default algorithm, so that you, whenever you will do some error, it will show you, means it will pop you the message that you are doing the error in that point. Okay, so the main advantages is this one, means you will get a high productive and a intuitive design environment, and also you will get to allow fold and unfold representation of the part. Okay, basically in our part design and this generative shape design, we cannot able to fold and unfold the view. Okay, but in sheet metal design we can able to fold and unfold the view. And the most important thing is, or you can say the advantages, we can work the sheet metal part with another application like part design, assembly design, or drawing generation also. So it includes many standard feature like stiffener, stamp, sweep feature, which are reduce the design error. So let's start with the sheet metal workbench. So how to enter into the sheet metal workbench? You can go to directly mechanical design and generative sheet metal design. Okay, so just go to the start, mechanical design and generative sheet metal design. Here it will ask you want to work in hybrid design or non-hybrid design. According to your need, you can set the, you can give the name and do the process like hybrid design you want or a non-hybrid design. Okay, now you are in the generative sheet metal design workbench. Okay, to make means frequently, if you want to use this sheet metal workbench frequently, again you need to do this workbench favorite, keep it in favorite list. So I'm just going to this tool, customize. Yes, generative sheet metal design, I'm taking it favorite. Okay, now you can find this one in your favorite list. You can directly go to the start and generative sheet metal design, or you will find here in the welcome to CAT-AV5 generative sheet metal design. Okay, now what are the general procedure for creating the sheet metal part? Okay, first thing is you need to add a sheet metal parameter. As you know, whenever you will create a sheet metal parameter, it should be uniform. Okay, the thickness and bend radius should be uniform throughout the process. Okay, so in the beginning itself, you need to fix the, or you need to give your sheet metal parameters or your standard. Okay, then after setting the sheet metal parameters, we need to create some wall, different types of wall, and that is your primary feature of your component. That is your primary features. Okay, after that, you need to add some bend like structure. Okay, then then whatever the thing means or operation you want to do, you can do in cutting or stamping operation. It may be your cutout or hole or a 3D features. Then we can see fold and unfold whether it is perform well or not. Okay, then we can modify the thickness and the wall after the end. In the end you can modify the wall. So I'm just going to the sheet metal parameters, just selecting this. So in sheet metal parameters, it will driven by the parameters bend extremity, then bend allowances. Okay, so parameters, you can see here you will find the standard, and you will get the thickness and bend radius. Okay, so if you are working with a non-standard with your own dimension, then you can go with this thickness. You can define this thickness and bend radius and perform the operation. Okay, if you want, if your organization have set some standard, let for example, in a design table they are maintaining some standard, like for aluminum the K factor should be different. Now you can see with this value, with this thickness 2 and bend radius 4, the K factor is 0.4. Okay, if I will go to change this one, let thickness is 3 and bend radius is let 8. Okay, now you can see the K factor is changed. So it is differ from organization to organization. So if you have any standard file, I have some standard file. I'm just going to this. I'm just going to the sheet standard and I will go with the aluminum. Let aluminum table. Now you can see my standard is aluminum and the thickness is 1. Here some defined already, some standard is defined, like from a whole clearance what is there, the bleed creation, bead creation, then if it has the thickness 2, 3, 4, what are the thing, it's already defined. Okay, it may be vary with the organization to organization, so according to your standard you can define that one. Let I will change to this thickness to 2. Click OK, and you can see the band radius already taken as 2. Okay, if you don't want to put with your in standard, you can go with your own dimension. Let I will go with this thickness 2, bend radius 4. Click OK. Now you can see after setting this sheet metal parameters, after setting these sheet metal parameters, all the tools, walls tools, roll wall tools, then bending tools, transformation feature, view, cutting and stamping feature, it's activated. Why? Because it needs some uniform parameter. And remember, whenever you will go for these sheet metal parameters, you must be specify the bend radius and thickness, and this you can set after that also. Okay, this you can set after that, or you can set in the beginning itself. Okay, it is optional. Okay, so is there any doubts on this sheet metal parameters? Basically this is very important whenever you will go for the sheet metal design. This sheet metal parameter you need to define properly, or else it won't be, means your part will be defect. Hope it is understand. Then we'll go for the walls. There are different types of wall. Okay, you can see normal wall, wall and edge, extrude, flange, hopper, convert surface, roll wall. Hello, is it clear, or anything you want from?
Sir, screen clear, sir. You
Okay,
can continue, sir.
okay,
We
okay.
are, we are listening, sir.
Okay, if you have any doubts, you can at that point you can ask to me. Okay, so here,
Yeah,
uh,
yeah, definitely, sir.
okay, why? Because it's online, so I cannot point out your problem if you will sit silently.
Yes, yes, sir. That is also one of the reasons, sir.
Yes, so whenever you have doubt, you can directly ask in that point.
Yeah, definitely, sir.
Okay, so basically this, see, you can see the walls. So wall, why you are using the wall? For just imagine the part design. For part design, we need a base sketch or base wireframe. Okay. Similarly, in for creating the wall, we always need a sketch. Okay. Without sketch, we cannot perform any wall. Okay. There, it can also created by using extrude. You can see here the wall may be created in extrude or a roll wall or a hopper operation. Okay, the wall you can create by this three option. Okay, one is extrude, hopper, and your roll wall, and then your normal wall. Okay, basically, what is the difference between extrude and roll wall? So this extrude, I'm just selecting the extrude. You can see it is asking a profile, first limit and second limit. It's similar with your pad in part design. Okay, there also you will get the first limit up to dimension, means dimension up to plane, up to surface, up to mid plane. Okay, similarly with the limit to mid mirror extend, automatic blend. Okay, so I have already one profile. Remember, whenever you will go with a open profile, that time extrude is comes to the picture. You cannot do any extrude when it is a closed profile. Okay, only in open profile we can do the extrude. Okay, you can see I'm just click on the extrude. Here also you will find the limit 1. I'm just going for the limit 150, and limit 2 I want 20, let for example. Okay, or else I'm just going to preview. You can see the sheet metal part is created. Okay, I'm just off this automated blend and preview. Okay, you can see if I off the automated blend, this blend is not creating. Okay, for that I need to check on the automated blend. It's quite easy, we are not creating anything. If you want to see the sketch, we are not create any corner or chamfer here, still it is automatically taken the blend. Okay, it's quite interesting. It is saving the time, and it is um, creating less, it is reducing the error also. Okay, by extrude with a automated blend, we can directly create the corner face. Then mirror extend means both the side it will create same distance. Invert the material, you can see now it is inside, now it is outside. Okay, I'm just mirror extend off inside the material, preview. Now okay, here it is outside the material, it is not taking. Okay, it's fine. Now here invert direction means you can change the direction. You can see here you can change the direction for thus, like here reverse the direction in part design. Okay, similarly this feature is available here also. Okay, now here it is sketch extreme position, sketch middle position, that I will explain in wall. When I will go for the wall, we can go with this. Again here it is blend, it's not required because k factor always taking default. Okay, this is how, if you have a open profile, that time you can go with extrude. Understand? When you have a open profile, as you can see this is a open profile, that's why I am going to this extrude. If it is a closed profile, then you can go with the wall. Let I'm just selecting the any plane, and I'm just creating, let I will create a open profile. Okay, and I want to try wall, creating wall. Now you can see it is showing it's not the profile should be closed. Please redesign the profile. Okay, so for that we need to close the profile or else it won't be create the wall. For open profile we can use extrude. For close profile we will use wall. Understand? Okay, and every time the thickness of the wall it is, every time the thickness of the wall it is 2 mm. Why? Because we have set this thickness in the sheet metal parameter 2 mm and the bend radius it is 4 mm. You can see whenever here also the bend radius it is 4 mm. Can go with the this and check the dimension here. Okay, this side it is 6 and inside you can see the radius it is 4 mm. Okay, so bend radius it is 4 mm and thickness it is, you can see the thickness here. Okay, you can see the thickness it is 2 mm. Okay, why? Because we are set this parameter in the beginning, sheet metal parameter in the beginning, and throughout the design it will follow the same way. Okay, now we'll see some of the option in wall. We can see some of the option in wall. Now I am just created the wall by using the profile. Now here it is, first one is sketch at the extreme position. I will just check on this sketch. You can see the wall is generated from the extreme position of the sketch. You can see here it is creating from the extreme position of the sketch. I want it should be in the middle. Preview. Okay, you can see in the sketch it is in the middle and in the top 1 mm material is added, in the bottom 1 mm material is added. Okay, this option is there, you can go with this. If you will go with the invert means sketch in the extreme position, you can go for the invert side, means other side, top side. Now it is the top side, if you want to invert it is coming in the downside. Okay, now here it is the tangent to the sketch. Okay, for that I have a very interesting example. Can see. Okay, now I want to connect this one with the one rectangular profile. So I will just click on the surface, go to the sketch. I will create a rectangle. Coincident. Coincident. Okay. Now if I will go for creating the wall. So this time I will go for the reverse direction. Preview. Okay. Now you can see here by seeing on itself, it is showing it is a different wall. It's not connected with this sheet metal. Okay, for that what you need to do is you need to go for the tangent and select the tangent surface. Then you can okay, select the tangent surface. Preview. Okay, yes, you can see it is connected to each other without going to any edge. Okay, this is how we can create the wall in closed profile. First one is open profile, second one is closed profile. Now in part design we are creating the 3D element in circular profile. For that we have one option, that is your rolled wall one. So what you need to do is, like, okay, so I have a open circle, so I want to create a roll wall, and as I said, the thickness is 2 mm. So you can go with the reverse direction for adding material in outside or inside, means you can go with this direction, should be inside. Again you can go with the mirror extend or symmetrical one. Symmetrical one means it the material is added both the side equally. Okay, preview. Okay, now you can see in extrude it is okay, means in extrude we can create the uh, 3D element or sheet metal part in open profile, but here in roll wall we can create the sheet metal part in open profile as well as in closed profile. Okay, so if I will go with this sketch, I want to close this one, and you can see I can able to uh, add the material in this circle. Okay, so this is the roll wall surface, means sheet metal. Okay, then if you want to go for fold, in that position it is fold and unfold. Okay, similarly here you can go with the fold and unfold. Now you can see I can able to fold and unfold. If you don't need, I don't need this fold and unfold operation in my sheet metal design. I want to do the design only. I don't want the features. Okay, so for that what you need to do is you need to disable the flat view calculation. So if you will disabling this flat view, let's see how to disable. You just go to the part body object. Here it is view. Here you will find the flat view active and deactive. Okay, if you will deactive and if you go for this flow fold and fold, it will it won't be unfold. It won't be all unfold because we have deactivated one. So what is the advantages if you will deactivating the flat view? What will be the advantages? So as you know, in generative sheet metal design, this sheet metal design, it will take more process for, as it is a standard element creation. So it will take more process or more algorithm. So it will take more time. If you will disassemble or deactivating this flat view calculation, then the process will be very fast. Your designing process will be very fast. After that we can um, uh, go for the view and activate again. You can activate and deactivate. There are two way to activate and deactivating the flat view calculation. One is with respect to this part body, just right click object and view, or else in the view itself you will get this view management. Click on this. Here you will find the view active deactive. If you deactivate means the flat view won't be generated. If you will activate one, now if you go for the flat view, it is making the flat view. You can see flat view on flat view. Hope you got the concept why you will go for deactivating the flat view, and if you will deactivate the flat view, what is the benefit? Okay, by deactivating the flat view calculation, it will increase the feature generation speed. Whatever the feature you will generate, it will create very fast. Okay, so as of now we have completed this wall, extrude, rolled wall and view. Okay, view, in view we have completed this fold and unfold, and here it is view management. Now the next one, it is your wall on edge. Okay, wall on edge. I want to create wall on edge. So click on this. I want to create a wall with respect to the edge. Here you will find two types of wall. Means two types in wall on edge. One is automatic generation, one is sketch based. Okay, in automatic generation you need to select one of the edge. Let it will select one, you will select one of the edge, and here you can see it is calculating with respect to height and angle, or up to plane or surface, or here it is orientation plane. So we will go stick with this height and angle. So my height I want 550, and the angle I want 90. Okay, I want the position should be reverse. Yes, it's in reverse, and I don't want this offset value. Okay, now you can see the wall is automatic generated without going for any sketch. Okay, as if you remember that one, when I start the sheet metal design, I said to you, whenever you will create the first level feature or a first wall, it should always created in the sketch, but the second feature, it may be the sketch, or you can directly generate the wall from the edge, or from the different features like bend or stamping. Okay, so here if I will change this one, according to that we can change the angle or that. Okay, now here I have added 50, the distance I have added 50. In distance, how we will calculate, you can see here the distance, the first distance. If you can see in the first distance, if you are able to see or not, I don't know, but it is clearly taking the distance from the bottom surface of the base part to the top surface. Okay, the distance is taking 50. The second, in the second, you can see in the second, it is taking from the surface, top surface of the first base sheet metal part to the dimension. The third one, it is taking the bend distance, and here it is taking the intersection of the two bend, two walls. Then here it is taking the intersection inside the bend, or you can say the center of the bend. It is taking the distance. Okay, I will go with the second option. You can see the size is increased. If I will go with the first option, the size will be decreased. You can see, you can observe here, second one. Okay, again here it is clearance and clearance mode. You can see here the clearance mode is no clearance. Okay, if I will go with the mono direction clearance, and I want to give some value, let 2 mm. You can see the clearance is changing, means it is going some 2 mm outside. Okay, if you will go for a by uh, directional, so it will go with, means directly it is taking 4, because our bend radius is 4. Okay, so from the end it is taking 2, and in the top, in the bend top also it is taking 2. Okay, and bend is always already there, so can go with the 4, because it already mentioned in the sheet metal parameters. It has some formula also, you can see clearance. Now in the next extremity, okay, if you want to create some limit, um, if you remember, uh, if you remember in sheet generative shape design or surface design, I have set some limit. Here you can set the limit without creating that limit value. Here already this option is available, you can just put the value, and it will you can see this one. Okay, okay, here. Okay, I want the no clearance and invert material inside it. Preview. Okay, now here here I have created the wall on edge, but here when I will go for this flat view, is it practically possible to bend this one, because it is already uh, closed, means there is no gap. It is if I will want, if I will bend this part, then automatic this will some disturb. Okay, it will create some disturb with this edged part. For that we need some clearance. Okay, so we need to give some um, relief on this. Okay, we cannot make connected to the part. So for that you need to go with the bend, and here you can see left extremity. Okay, I will give the clearance minimum with square relief. In the second one also, in the right side also, I want to give minimum with square relief. Preview. Okay, now you can see now it is possible to bend, because I have given some clearance, some relief. Okay, there are different types of relief. You can see here the different types of relief. One is here minimum with square relief, minimum with round relief, linear shape. Let I will select this one, linear shape. It will automatically match with the end surface. Okay, if I'll go with the unfold, you can see like that. And also if you will go for a cut, it is easily to cut the material. Similarly with the other side, extremity, sorry, here bend. In the right side I want like okay, this type of preview. Okay, in this way you can refine the wall on edge. So this is one type of wall on edge. Now it is creating automatically. Okay, now the second type of is sketch first. It is sketched base. Okay, for that we need a sketch. Okay, I'm just creating one sketch. Okay, as the name is it suggesting wall on edge. For that, if even you are selecting the uh, sketch, sorry, when you will create in a sketch, for that also, for this also you need to, for sketch based feature you need to select one of the edge for creating the wall with respect to the edge. Now I will select, I'm just selecting the edge and going to this profile. Now see the magic of this. Just creating a rectangle, anything. Okay, whatever the thing you want to create, you can create. Okay, now you can see it is automatically taking the sketch. I don't want the bottom side, I want the reverse position. So I'm not done anything here. I'm just done the profile. I'm not create any cutout feature also here. I'm just creating the profile and run this one by with respect to edge. Okay, here also you can give the clearance something or some relief. This in the second also want this preview. Okay, you can see I've given some relief. We created wall on a edge with respect to the sketch. Okay. Now the next one is your swept wall. Okay, so it is like a standard type feature. Okay, swept wall is like a standard type feature. Similarly, you will find some standard feature here is stamping. Okay, this two is standard one. Okay, if you won't give any proper value that time in that condition, it will show you some error. Okay, this swept wall and stamping, it's a standard feature. Okay, for that we need to give some proper means exact value. If you give your own value, then may sometimes it will show you the error and it will directly tell you it is not possible to create the wall. Okay, so we'll go with this swept wall. Okay, there are different types of swept wall. One is your flange, then hem, tear, teardrop, then here is user features, user profile. Okay, so I will go with this flange first. You can see I will select one of the edge, select one of the edge, and you can see define the length and angle for creating the swept wall default. Okay, if you want to perform this thing in a part design, for that to lot of thing need to be do. You need to go for the sketch and you need to go for some um, corner and give some angle line, incline line, give the dimension, and all this thing is required. But in generative sheet metal design, we can perform the wall within a single click. That is the main advantages. And here the you will get the feature very you will generate this feature uh, will be very speed, and that should be reduce the error. Okay, it will reduce the error. Similarly, you can go with this hem. Again here, hem, you can see the icon of this hem. Here the radius you need to define, and the length. Radius it's already there, it is fixed with throughout the sheet metal design, because we have added this sheet metal parameter. Your radius is 4 mm and the thickness is 2 mm. That's why it is taking the formula directly. You can see here that it is taking the formula from sheet metal parameter bend radius. Okay, and you need to, if you want to change the length and angle, you can go with that. And here you will find the trim support or reverse direction also. You can give the reverse direction for creating the hem. Okay, similarly you can go with the teardrop. Going to this, and here also you can define the length. So why we are using this this swept like feature? Because sometimes our part is it's perfect, but for strengthening the part we need have some stamping feature or swept wall. Okay, if it is a long feature like a cantilever type beam, we need to give some bend like structure, so that whenever the force will be applied, then it it will give a less impact. Okay, that's for that for that point we this swept wall and this stamping feature will come to this picture. Okay, okay, now here I will just going to the simple flange. I'm just selecting this edge. Okay, while selecting this edge, it is selecting only one edge, but I want to perform this flange throughout the profile. Okay, throughout the profile. So for that, if what you need to do is you just go to the propagate. Automatic, it will take the profile which is tangent to each other, or you can say the tangent continuity or curvature continuity. Okay, when you will go for this propagate, it will calculate the tangent continuity sometimes, or if it is a curvature, it will directly take. Okay, but point continuity, it won't be take. Why? Because in point continuity there will be a sharp edge, there may be a sharp edge. Okay, so you can go with the this one. You can here also you can give the reverse direction, this. Okay. Okay, so as of now we have complete the how to create the wall in closed profile, how to create a wall in open profile with a some option like default option like your band radius or creating band. Then we have create the role wall where the open profile and the closed profile came to the picture. Now here it is one option hopper. Okay, so what is hopper? Okay, once I click on this hopper, there are two types of a hopper. So just generally, hopper is a sheet metal wall created between two sketch. Okay, which is parallel to each other, or a non-rule surface which are continuous in tangency. Okay, so maybe hopper, if you go for this conic hopper, that time the hopper is used to sketch which is parallel to each other. Okay, when you will go for the surfacic hopper, that time again it is divided into two types. One is rule based surface, one is non rule based surface. But in the non rule based surface also, it it need the minimum requirement like tangency continuity. Without tangent continuity, it won't be go for the creating those sheet metal parameters. Okay, so we'll go with this conic hopper. So I have some input that I believe. Yes. This conic hopper, you can say this is a multi-section like generative shape design or part design. Okay, I'm just selecting this hopper and selecting the conic hopper. So while click on this conic hopper, it is showing the first profile. It is asking actually the first profile and second profile, and the first point and second point for opening line. Why we are using this sheet metal design? Basically we are using the sheet metal design to fold and unfold. This feature is there. Okay, so I'm just selecting the first element or the first profile and the second profile. I want to open this profile or this sheet metal parameters in this point and this point. From this point it will be open and preview. Okay, you can see automatic, it is taking the material, sheet metal material, and you can see when I will go with the fold on fold, in that point only where I have mentioned the opening point, you can see opening point it is mentioned. Okay, you if you want to change this direction, all means whenever you will unfold, it will open in that direction, in the opposite direction. Okay, this is how the canonic hopper is performed. And another is surfacic hopper. Okay, for that, for surfacic hopper, let I will create another body, just hiding this. Okay. Just deleting this one. So this normal hopper, there is no doubt, I believe. So how we will create the hopper? By using the two profile. And remember, whenever you will create the hopper, you need the profile which is parallel to each other. Okay, is there any doubts on this hopper, guys?
Yeah, no, sir.
Okay, fine. Now I am creating the rule based surface. Okay, I'm just, for that I need a surface actually. So I'm just selecting the multi section, first one, second one, closing point. Yes, it is taking the closing point in same direction. Preview. Okay. Okay, I'm just creating one line for opening line. Okay, and project the line, project the line on this surface. Okay, it's not required actually. Okay, now I'm just switching to generative sheet metal design, and I want to do the hopper. So this time, which type of a hopper you need to perform? We need to select the surface hopper. Okay, this is a rule based ruled surface. Okay, there is no non-uniform surface. It is a uniform surface because I have used the multi section. Okay, I'm just selecting the surface, and you can see it is by default taking some OR for this reference OR for opening the part. You can see this opening part is here, but I want to open in this edge, from this edge. Okay, from this edge, and the point I want this, and preview dear OR. As I said, for a create means for executing this, you need uh, means it will take some time. Okay, because it is calculating some standard, some algorithm and all in a generative sheet metal design. So here inside, in both the side, other side I want means yes, tier where is selected. Yes, you can see. Okay, this surface is directly means this sheet metal is directly coming from the surface. It is only possible whenever you will create the surface hopper from the rule surface. Okay, if you want to go for, yes, it's coming like this. I want to open from this point. Okay, tier wire should be this. Just creating the hopper. Maybe the closing point is different. Open from this. Okay, I want to open from this, means unfold from this. Preview. Okay, now if I want to, I'm just hide this generative shape design and this sketch also, and want to unfold. You can see in that tier edge it is unfold, fold and unfold, fold and unfold. Okay, now this is how we can create the sheet metal part from the ruled surface. Now we'll go for the non-ruled surface. Now you can see it's a complicated surface. It is a complicated surface. Okay, and you can see the surface is there. Oh, it's a blend surface, and here the sheet metal parameter is not added. That's why all the tools is not activated, so we need to add the sheet metal parameters with some thickness. So I don't think it's a complicated one, complex one. So I don't think 2 thickness will be take to this. So I will give only 1 thickness, and radius I need to calculate this one. Surface radius. Radius, okay, it's not coming. Okay, so I'm just try with one thickness, 1 thickness, just going with to the hopper again. So as it is a surface, already we have surface, and here I think it's a continuity, tangent continuity surface. So I'm just selecting the surface, and the T or OR means the surface will be open from this. Okay, default it is taking this, and preview, and it is updating the non-ruled surface. Yes, it is opening from there. Okay, here you can find the distortion. You can see here it is find the distortion. So after opening, if you will create the hopper by using this uh, by using the surface, you can see the defect directly from the flattened surface length distortion. Whenever you will open that one, the surface will open or unfold, that time it is creating some default defect or not, that you can see in the distortion itself. Okay, as it is a complex edge, sometimes it is creating some defect. Okay, here you can see it is in green color, and some portion it is have some defect, but that is negligible. Okay, close, preview. Okay, now if you will go for the unfold, it is coming with this. Okay, so this is about the hopper. There are three types of hopper. One is your conic hopper, one is your surface hopper, surfacic hopper. Again, the surfacic hopper is divided into two types. One is rule based hopper, one is non-rule based hopper. Okay, now we will go for this convert surface. Okay, so in a hopper, if you have a ruled surface or non-ruled, means it's already the surface component is you designed, and you want to make it in sheet metal design, then you can go with the hopper. If a sheet metal part is there, and inside that it is like a hybrid design, inside that you have created some surface, that time you can go with the free form surface or convert surface. Okay, so basically this convert surface also it is in three types. Okay, you can see whenever we will go for this convert surface. Okay, it is three types. One is free, one is connected, one is fixed. Okay, free from the surface is a sheet metal feature generated from the free from surface connected to non-connected. Okay, so I will go with the free surface. I want to create the sheet metal part. Now you can see I have selected this one, and it is creating a sheet metal part. If I will go with the unfold, it is unfolding. Okay, just simple surface. from the simple surface to convert the sheet metal part, we can go with this free form surface. Okay, then one is your connected surface. Now you can see this is my, okay, here this is my one of the sheet metal part. You can see it is one of my sheet metal part, and inside that I have attached one of the generative shape design or a surface. Okay, it's surface. I want to create a sheet metal part which is connected to this sheet metal part. Okay, for that what you need to do is you just go to the converting surface. This time I need to select the connected. I need to select the surface to be connect and preview. Okay, here some points you need to check before creating the connecting surface. You need to check some points. The surface should be tangent to the existing sheet metal part. Okay, and by default it will take the thickness, there is no problem, but this profile should have the uniform cross section, means it will follow the tangent continuity or curvature continuity. If it is follow a sharp edges or point continuity, that time it's not taken, the this sheet metal part won't be taken. So preview. Okay, you can see it's now it's a connecting sheet metal part. If you will go for unfold, it is unfold now. Just hide this one. Okay, fold unfold, I can able to fold and unfold. Okay, then the next one is your fixed edge. Okay, the um, edge fixed edge converting surface. Okay, so last time when I used the free one, it is opening from this I want to open from this, and this edge to be fixed. So for that I'm just selecting the face, and fix edge I am just selecting here. Okay, inside preview. Okay, now the sheet metal part will open from this side. Okay, as you can see the my pointer, it will open from this side. So I'm just open this one. You can see the sheet metal part is open from that side, and this why, because I have fixed this edge. Okay, 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 is there any doubts up to this?
System is upon.
Hello.
Yeah, okay, sir.
Okay, can you take some 10 minutes break?
No issue, sir. Okay.
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 Okay, now you can see I have two wall, wall 1 and wall 2. Yes or no? But here if I will go for this fold and fold, it is not performing. Why? Because we don't have any bend structure or any shape which will create the bend. Okay, for that we need to create a bend between these two part. Okay, for that we have one option that is bend. Okay, there are, you can see there are two types of bend. One is your bend, normal bend means the bend will create with a uniform cross section. Another is conic bend. Okay, another is conical bend. The bend will create with it variable dimension. Okay, so I will go with the normal bend. Like, so here I am selecting the first support and second support. By default it is taking the radius, it is 6 and angle 90 degree. Okay, so preview. Okay, here you can see now you can perform the fold and unfold. Yes or no? Why? Because we have create a shape which is needed to fold the part, required part. Okay, so for folding that, if you created two walls, and for folding the part we need a bend. Okay, so here in the bend itself you can, if you go to the more, you can add some relief. You can add some relief for creating a proper type of bend. You can see I have added here a circular relief and here a rectangular relief. Okay, this is cylindrical bend. Go to more, and here automatically the k factor is consideration. As you can see, the k factor is coming with some algorithm. There are some formula is applied in the k factor. Okay, it will directly take the value from your thickness and your bend radius. Okay, and you can see the bend radius here, it is 6 and the thickness is 4. Okay, means here the bend is created of radius 6 and the thickness is 4. So you can see when you create the bend, it will create the thickness here 6 mm, but in the outside, sorry, inside radius it is creating 6 mm, but outside radius, what is the value? Your inner radius plus the thickness, means outside radius it will be the 10. If you will calculate that one, you can see the radius it is 10. The radius it is 10. Radius it is 10, but inside it is 6. So now the thing is that to the thickness is equal to outside radius minus inside radius, then you will get to know the thickness. Okay, that is the formula of the sheet metal design. Okay, that is the actual the rule of the sheet metal design. Okay, this is how we can create the cylindrical band. Now I'm just deleting the cylindrical band. Now I will create the conical band. Okay, similar here also it will ask to you the support, first support and second support. Okay, here there you have only one radius, but here in this you will get two radius. One is radius, left radius and right radius, as I said before. Okay, so conical bend, it is just like the variable fillet, edge fillet in part design, but in the part design you can add multiple number of points, but here in the conical blend only two radius will be involved. So preview. Okay, you can see this side it is just, yes, this side it is 10, this is only 2, sorry 3. Left side it is 3, right side it is 10. and here you can define the left extremity as per your requirement. You can give some relief, you can see like that you can perform the thing, unfold it. Okay, now the next one is your bend from flat. Okay, if you have a flat surface and you want to bend, okay, from the middle or from any edge, okay, for that what you need to do is bend from the flat. Now you can see this is a flat surface. Okay, I want to bend two bend. I want to create two bend by using this flat. So here I will go with this bend from the flat. Select the profile line one. I want to bend in line one preview. You can see line one is inside. Okay. Here also you can see in line one you can define some parameters here also. I want the angle, I can change the angle here, let 113. In the line 2 I want some angle, let 113, again same, and you can see it is bending from the flat. Okay, now you have done on the bend from the flat. Now I want to, I have this folded part, I want to unfold it. Okay, I want to unfold the part. We can go with the unfold directly, this directly the view unfold, but it is unfold um, total in the total feature. It is for unfold the total feature, but I want to unfold this one only. For that we have one option, bending option. In the bending we have one option, that is unfolding. Here you need to select the reference face. I want this reference face, I want to unfold this. Okay, reference face, unfold face is this one. Okay, unfold face is with respect to this reference face. Yes, this edge you need to select and preview. You can see now it is unfold. That particular face is unfold with respect to the reference one. Again I want to unfold this one with respect to this. So for that what you need to do is you need to select the unfold option, select the reference face and the edge for unfold. You can see again I want to unfold the other one. This one is my reference one and this to be unfold. Like this you can unfold one by one. Okay. Again if you want to fold, again same thing. You need to select this one and select the bending face preview. Okay. You can see it is folded, first level folded. Then again if you want to fold, select the reference one, go for the face, then again fold. Then the next one, select the face, select the folded one, preview. Okay. In this way you can fold and unfold by using this fold and unfold option. Okay. Here we have completed the bend from flat and folding one. Then next one is point or curve mapping. Point or curve mapping. Let you have mapping. Mapping, yes. Sometimes while going to the construction or some stamping, for that, for notation, we are using some mapping, pointer curve mapping. So as you can see, if I will go for this unfold, you can see it is a sketch. I want to put this sketch in is one of the surface of the sheet metal for a marking purpose. Okay, so what I need to do is, you can see here, I will go to this and I can define the unfold characteristic element or construction element or marking for marking purpose or for engraving or user defined is not there because some standard is required, but for construction only or for marking. Okay, for marking I am just selecting this one, and the support I don't want the support of both of these. If I will go with the default support and unfold, you can see in the both the side the sketch is marked. Okay, but I don't want to mark the both the side. So for that, what I need to do is I just go to the marking for marking purpose. Just go to the marking, select the object, and the support I want this only in this sheet metal face. Click OK. And if I'll go for the unfold, it will marked on that particular surface or okay on that particular element. This is how we are giving the marking in the sheet metal part. This is all about bending. Now the next one is your cutting or stamping. So basically cutting is used to remove the material. Cutting and stamping is used to stamping is like a standard tools or a standard element which is used to strength strengthen the sheet metal part. Okay, strengthen the sheet metal part. So we'll go one by one. One is your cutout. I want to remove this rectangular face from this sheet metal part. So for that, what you need to do, you can see this shape. It is similar with the pocket. Okay, similar operation also. It is if you will select the type, there are two types of means cutout. One is your sheet metal standard. One is a sheet metal pocket. In a sheet metal pocket, if you will select this one, in sheet metal pocket, it will give you some dimension only. Okay, if you will go for the sheet metal standard, it will give you the up to next up to last option. Okay, so let we keep with the sheet metal part. I am giving the dimension only and preview. Now you can see I just remove the element of the sketch. Okay, then the next one is your hole. It is same with your part design. We need to hole is a standard tools. We need to select the surface where you need to create the hole, and here you will get the positioned sketch. There you can define the proper position of the hole according to your requirement. Now it is a parametric one, and here you can go with the blind, next up to last up to plane surface. There are different types of hole also. It is similar with your part design. Taper hole, counter hole, as it is a sheet metal part, so it may not be used, um, because for that you need a proper um, thickness, and here you can go with the thickness threaded. Okay, let go with a simple hole. Okay, and see the change. You can see in the simple hole, Okay, in the simple hole you can see here it is not taking any, here one. Okay, it is not taking any type of symbol. Okay, if I will go with the, if I will go with the hole with threaded, it will show you some symbol so that you can understand it's a threaded hole. Okay, it's a threaded hole, you can understand. Here you can see a thread type symbol is came in the picture. Okay, it's a threaded hole. Now here it is a circular cutout. Circular cutout is basically used in the bend. Okay, in the bend if you want to cut some part or cutting the circular one, you can go with the circular cutout. It is easily cut that, because for this circular cutout means for this bend, we cannot take the reference sketch. Okay, as it is taking the reference sketch, but it is taking from the absolute axis. Okay, again another one is there in cutout. Mm, one is there. Yes, cutout using cylinder. Okay, I'm just see one of the plane is there. I want to cut from the here like a cylinder. So I'm just giving one, is taking this plane and create one circle. I want to cut. So what I need to do is go with the cutout. Okay, up to next means only this. Up to last means only this. But I want to go with the dimension. Dimension. Let 100 preview. Okay, it has not reverse side, reverse direction, and give the 200 depth preview. Okay, this way you can see the cutout is performed. But I have selected this one in round means a circle, but here it is coming in ellipse type because of this angle of the plane. Now corner. Okay, so corner is like it will create a rectangular means, sorry, circular shape. It is similar to your part design. You just click on this corner, you need to give the define the corner edge and define the radius preview. Okay, you can see the corner is defined. Again, in chamfer there are two types of chamfer. One is length and angle. Let's go with the length and and angle. Length I need to define preview. Okay, you can see corner and chamfer. Corner it is coming with a circular round type structure feature, but in chamfer it is coming with a flat feature. Okay, now here it is your corner relief. It is very important when you will unfold or folded in the manufacturing process. Fold and unfold in the manufacturing process. So I'm just going to the particular what is corner relief. Now you can see it's already some relief is there, but I want to make a corner relief. Okay, while creating on this, you can see one is circular corner relief, one is square, one is user profile. So user profile is there. I will go with the circular and square. Okay, so this corner relief is only possible when it is a unfold view. Okay, you can create it in the unfold view. Just selecting the unfold view, and I want to go with the corner relief and select the two face, two support face for relief and increase this. Yes, you can see it is a circular. In the circular form, it is, you can see here, in the circular form, it is creating the profile, and the radius it is 50. Preview. Okay, you can see it is relief in circular form, and you can go with the unfold here. Okay, similarly, you can do the same thing in, if you want to give some extra relief on in the form of a square. Yes, this in the form of square, you can go with the square also. It will cut the it will create the relief in the form of square. You can go with the unfold one. Okay, then the next one is your next type, it is your user one, user profile. Select the user. So for that, what I need to do is I need to close, sorry, delete this one. Now I want to relief with respect to this profile. So what I need to do is just go for the corner relief, user profile, select the profile. Okay, as I said, you need to be unfold this one. Support is this one, preview. You can see with respect to that profile, it is giving the corner relief, and you can unfold it. Okay, this is how we can perform the cutting with respect to the sheet metal part. Now the next one, it is your stamping. So as I said, for stamping is basically used to strengthen the sheet metal part, strengthen the sheet metal part. So I'm just going to some stamping. Okay, there you will find stamping. Will find the surface stamping. One is bead, one is lower, flange cutout, lower, bridge, flange to hole, circular hole. Here this one is a stiffening reef. This is very important when you have a normal wall. That time it is used, and it's long. If you have a long wall or um, a sheet metal of L type structure, that time stiffener is used. Then here it is your dual and a user stamp. So I will go with the surface stamp. You can see here, just click on the surface stamp. As I said, it's a it's a standard tools. The stamping is a standard one. If you will go with it your own dimension, let I will give you my own dimension, own radius, own radius, own height, it will show you some error. Yes, you can see the update error. The fillet between the stamp and its support cannot be computed. Check the radius value. Okay, so you need to take care of the value. Let I will give the height to 6 and radius I want to give let 3. second radius. You can see the icon. Okay, thicken. As I said, you need to give some proper value. So I'm just giving this one. Okay, preview. Surface. Yes, preview. You can see it is going with the height 13 and the radius 1 and radius 2 it is making. Okay, similarly you can go with the other one for surface again this, and here we have three profile. I need to give a surface. You can here one of the feature is there, half years. Half years means it will take the half, means round one it will be the it won't create any radius, it will give only the height. Okay, let each one preview. You can see the height. Okay, other side. Similarly here can go with the, this time I want one. Okay, this thing can half years. Other side. Okay, like this you can perform the stamp, surface stamp. Now next one is bead. For bead we need a line. So as I said to you, this thing is required for strengthen the surface or strengthening the sheet metal part. You can see I just go to the bead. Here you can apply your dimension. If I will go with the wrong dimension, it will show you the error. Okay, you can see I can go with the height also. Okay, the height is should be less than equal to radius 2. So I need to increase this one. Preview. Yes, this one I can increase. Yes. Okay, so basically why this we are using this thing for strengthening the the sheet metal part. Again it will create a less error, it will reduce the error, human error for creating. If you will create this thing in your normal sketcher, then you may get some error while going to the manufacturing process. But if you will create this thing in a generative sheet metal design, it will give you some less error, it will reduce your error, human error. Okay, then the next one, flange get cut out. Again for flange cut out we need a profile. Let I will create a profile rectangle. Okay, I need to remove flange cut. Okay, it is showing should not be flange cut out. Yes, Just going to the flange cutout, selecting the profile, and you can see by default it is taking the height. You can increase the height. Okay, it's enable. As I said, it's a default or standard one. Please check stamp is not allowed in that. 6 3. Yes, you can see other side it is flange cutout, flange hole. Then the next one is your flanged hole. Preview. Okay, like this the hole will come. Okay, that is with respect to profile. This is with it is create default in hole, flange hole, as the name suggesting. Then the next one is your stiffener. Okay, lower also is there, so I'm just creating on the lower. Yes, this one. Okay, I want to create a lower here. So lower it is just basically used to vent opening a part. Okay, so it's there. I want to select the opening line where I want to open the part. So sheet metal part, you can see here the lower is created and the opening part is selected in the top. I'm just selecting the line. It is air vent. The next one it is very much useful in industry for strengthening the part. One is here stiffener rib. So for that we need the bend, and we need to give the length as per your want to be. Okay, you will find this type of features for strengthening. Now earlier again you can fold on fold, you can see this. Okay, so if this stiffener rib is not there, you can directly easily fold this one. The strength will be very less, but when I will go for this stiffener rib, the strength will be very high. It is very difficult to break. Then here a dual also it will be like this. It's just like this dual. Okay, you can see, you can increase that one. Preview. Okay, like this it will come. This is how we are creating the sheet metal design in different tools. Okay,
Hello.
yes,
Yes, sir.
is there any doubts on this?
No doubt, sir, but we are not getting any display, sir, from your side.
Yes, I just stop the display. If you want uh, any practice content, I will share to you.
Yes.
Just give me 2 minutes.
Arshit. Ecil. Okay. Okay. Only T. Okay. Arshit Kumara. टू मेंबर हाँ उन लोगों का नाम क्या ओके सर here we have provided all names sir
Okay, just a second. I'm just
sir you
taking.
can see sir
Yes, yes. I want to show you something. You can try this one also. You can take the screenshot. You can go with this exercise also.
okay sir
You can go with your own dimension. Yes, if I will give the dimension, you can do it very fast, but you can go with the dimension, your own dimension, and try to achieve this picture.
okay sir
Okay.
okay sir
చూడు నీ కొట్టు నువ్వు కొట్టు ప్రింట్ స్క్రీన్ రాలే బాబు
print చేసినారా
Have you taken the screenshot?
yes
Or-
yes
okay. So hope my session is useful to you all. So it's
yes
hope it is interesting also.
thanks for your
So thank you everyone for giving your time.
thank you sir thank you for thank you sir